All right. Okay, just going through the odds real quick, and then we'll move on. If you have questions, just stop me. But numbers 1 through 5 there, again, you were trying to find the missing measures for X. So on number 1, you had 2 chords that said was the same length. Therefore, the 2 arcs that they're intercepting had to be the same. So since the one side was 79, the other side was also 79. On number 3, you have the 2 chords. They gave you values for the 2 arcs. They had marked as congruent. So since the arcs are congruent, the chords had to be the same length. So you set the 2 chords equal to each other. So saying those equal and solving, you should get 24. On number 5, you had the one arc that was given to you was the 114. You weren't given either of these. This was labeled as X. Since these 2 chords are the same length, then the 2 arcs had to be the same length as well. So since that's X, this would also be X. We can subtract the 114 from 360. Whatever's left, we divide it in half to get the 2X values, which was 123. Those were the first 3 problems. Any questions on those? Let me go back and actually show work. All right, let's move on then. All right, on the next set. So now, this is down at the bottom. Again, still doing just the odds. On number 7 through 11, they gave us the radius was 34. They said AB was 60. They told us that the arc AC was 71. Find each measure. Now, since AC is 71, the other half of the arc is also 71. So that was our answer for number 7. Since they told us that the entire line AB was 60, that line, since it's perpendicular, is bisecting it. So split 60 in half. Each one of the 2 parts of the chord would be 30. For the last one, you would have had to draw in an extra radius in order to solve for that missing piece. So here, that radius was 34. And once you had that radius, you had a right triangle. So we're using Pythagorean theorem. Set up Pythagorean theorem, solve for the missing piece. And this one, the missing piece was 16. Now, could you have done that a different way besides using Pythagorean theorem? Yeah, again, we got all whole numbers there. It is one of our triples. Now, is it a triple I would have expected you to recognize? Probably not. This one, so we had 34, we had 30. If we divide both of those by 2, it was 17 and 15. The missing side would be 8. 8, 15, 17. Again, it's not one of the 2 that I said you have to memorize. Again, these are the 2 that you definitely need to be familiar with. But if you knew that one, it would have saved you time. Again, I would expect you probably Pythagorean theorem. All right, moving on. 13. You have this figure. Both of these are the same distance away from the center, therefore they have to be congruent. So they gave us the measures on those 2 lines. We're going to set those 2 measures equal and solve. So we have 20 is equal to 5x. Divide by 5, and x was 4. Any questions on that part of the worksheet? All right, moving on then. On the back. On the back, same thing. Again, setting them up. Just going to read through the answers this time. If you have questions that you want me to go back to, let me know. On number 1, the final answer there was 7. On number 3, the final answer was 4.5. On number 5, the final answer was 60. On 7, the final answer was 30. On 9, it was 5. And then on number 11, that one was a little bit different from the front, so let me explain that. You had all these different measures. All right? Out of all those measures, you're trying to figure out which one of these chords had the same length. Well, in order for the chords to have the same length, their arcs that they intercept would have had to be in the same measure or same length. So this one was 110, so I highlighted it there. This one, if you add these 2 together, was also 110. So AC and DE were the 2 that were congruent. Any on that page that you want me to go back to and go over? No? All right, we're going to move on to other. Page here. All right. So now, looking at the other paper that you have, that I passed out today. On this one, now, I think there's some additional things that aren't on here. Again, I'm trying to avoid giving you guys a lot of handwritten notes in this section, because at the end, I'm going to have you guys summarize everything on one sheet of paper so you have something to study from. But there's a lot of different properties. So on this one, there are some that are listed on here that will help you out, but I'm going to list a few other things off to the side. On this first one, so inscribed angles. Now, we've had that word inscribed before, right? And I'll talk about where we saw it when we go over the other half of the worksheet. But inscribed angles are angles that are on a circle, and the rest of the angle is inside of it. So here we have this angle is an inscribed angle. The vertex of that angle is on the circle. All right. Now, we had the idea in the not last chapter, in chapter, what was it, 10.1, I think was the section, where we had a circle, we had a central angle, and we said that the central angle was equal to its intercepted arc. So let's say for a second, this looks like it's about 40 degrees. And we say that's 40 degrees. Now, an inscribed angle, a little bit different. If we draw an angle using that same arc over to the other side, it's not going to be the same. And we can clearly see this angle is definitely bigger than that angle, right? The angle got smaller. An inscribed angle is exactly half of the measure of the intercepted arc. So this arc is 40, this angle is 20. So you can say this one of two ways. Yeah. An inscribed angle is half of its intercepted arc, or you can say that the intercepted arc is double the inscribed angle. That's what the main idea that they're using on these problems. Now, there are some other important ideas that come from this main theorem. So let me draw a couple other circles real fast. If I had a circle and we had the diameter drawn in. Well, I know that's the diameter because it's going through the center. Now, with the diameter drawn in, each half of that circle is what? How many degrees? 180. So let's say, all right, down here, this is 180 degrees. If I had an inscribed angle that's drawn into half of a circle, into a semicircle, what does that angle have to be? So we just said inscribed angle is what compared to the arc? Half of it. So if this is 180, that has to be 90. It's all right. So it has to be 90, right? We're dividing that in half. Now, it looks a little bit different because I drew in the diameter, right? If I had drawn in the diameter, you probably would have seen it like, all right, we have, this is 180, that's going to be half of it, so we're going to have 90. Now, a lot of times they're going to have a diameter drawn in, and whoops. All right. So, again, on here, the diameter might not be drawn in on figures, but a lot of times they may draw the diameter and not give you any types of measures over here. And you have to know that anything that's inscribed into a semicircle will be exactly 180. Now, it doesn't matter where you actually draw that. So I drew this angle. If I drew it off to the side, it should still make a right angle. If I drew it off to the other side, yeah, no matter how you draw the inscribed angle, if it's inscribed into a semicircle, it'll always be 180. Now, that brings us to another idea that we use a lot. If we have a circle and we have two separate inscribed angles, one inscribed angle, here's another one, and they're intercepting the same arc. So on here, both of these are intercepting this arc, right? What's going to be true about those two angles? Those two angles have to be, you said that. They're going to have to be congruent. They have to be the same measure, because this angle is going to be half that measure. This angle is going to be half that measure. So they're going to have to be the same, because they're based off the same arc. So if this was, let's say, that's a little bigger. Let's say that's 60. Each of these would then be 30. So they have to be congruent. So two inscribed angles that are intercepting the same arc have to be congruent. Now, I'm going to leave those up here. Let me roll this up. So let's take a look at these examples down at the bottom. All right. On number 1 there, this time they gave us the angle and they're asking us for the arc. So they want this arc here. Well, compared to the angle, that arc should be what? Same? Double, right? So the arc is double, the angle is half. So here they gave us the angle, so we're going to double that. This arc is 72. On number 2, they go the other way. They give us the arc. We want the angle. So we're solving for the angle this time. Well, the arc is 62. The angle is, let's half that. 1. On number 3, they want that entire big arc from Q through S all the way around to R. Well, you have 113 degrees for the angle. What's the arc? It's going to be quite big. We have to do that measure. We don't have to subtract it. Again, same idea. Just double it. All right, just double it. You have 113 times that by 2. This whole thing is 226. The bottom. These are based more off of this idea right here that we just talked about. When you have two angles intercepting the same arc, they must be congruent. So first, they're talking about angle U. Well, angle U is intercepting this arc. So is angle B. So angle U and angle B must be congruent. So if B is 30, then U is 30. For angle T, same idea, because now we also have angle T is intercepting the same arc as angle W. Now, instead of having just a measure to set equal to, they give us an expression. So we have to set those two equations or expressions equal to each other. And we have to solve. So bring your like terms to the same side. We have the x's, take that 2x, bring it over to the other side, you get 1x. Take the 4, get it over to the other side with the other constant, subtract 4, subtract 4. That's now. That's it. On 6 and 7, you have a new figure, but it's the same idea. Take a second, solve for A and C. See what you get. Again, using the exact same idea as what we just did. Solve for A and C there. See what you get. Have you done this part already? No. 3, 4. All right, so on these two, again, we have them equal, so angle A is intersecting the same arc as angle D. We both had a y in their equation, so we set those two equal. We had 6y minus 2 equals 5y plus 8. We can bring the 5y over, leaves us with just y. We can bring the 2 over the opposite way by adding it, gives us 10. Y is 10. They wanted A, so we need to actually plug it back in to get the measure of angle A. Make sure you answer for what it's giving you, because we don't want to stop at y there. Take the 10, plug it in. 6 times y is 60, minus 2 is 58. Plug it in. That's 6 times 10 minus 2. That's how we got the 58. On the next one, we have these two angles, B and C, also intersecting the same arc over here. So they were congruent. So we're going to set those two equal. 6x minus 3 equals 7x minus 11. 6x, we got to bring it over to the other side. So we're left with just x. Then bring the 11 over. Add 11. 11 plus negative 3 is 8. I had somebody in my last class ask, why do I sometimes have my variable on one side and sometimes have it on the other side? Again, it doesn't matter what side you bring your variable to. You can bring it to either side. Anytime I go through and solve an equation, I normally move the variable first so that I'm making the variable a positive number. So I always choose to move the smaller of the two numbers with the variable over to the opposite side so that I have a positive variable. That way at the end, I don't have an extra step to multiply or divide by a negative number. Again, it doesn't matter which way you move it. So again, on that one, we got x is 8. Once you know what x is, now we plug it back in. Again, they wanted C. They want this angle this time. Plug it back in. 7 times 8 minus 11. 7 times 8 is 6. Minus 11. Minus 11. 45. All right. All right, you good on that page? Wait. You say you get the copy? Right. Moving on. On the other side. On the other side, we have. Wait, what was one for? The answer. Oh, the page. This is page, yeah, 24. Okay. So this one's talking about inscribed polygons. Now, we actually talked about an inscribed polygon before. We talked about an inscribed triangle. Right. So back when we were doing triangles, we had points of concurrency, an in-center or circumcenter. And when we had those parts, we talked about circles being inscribed into a triangle or circumscribed around a triangle. So we've used the term inscribed before. Inscribed is basically meaning inside. And specifically, if we're inscribing a polygon, we're going to have all the vertices on the circle, and all the sides of the polygon are going to be chords. So again, all the vertices are on the circle, all the sides are chords of the circle. Now, they do hit on the idea I had on the last page. but they do it kind of in the backwards order. So it's kind of like the converse of what we had said on the last one. I had told you that if you have an angle inscribed into a semicircle, then the angle had to be a 90-degree angle. This is saying if you have a 90-degree angle, then you know it intercepts the diameter. So again, if you have an angle that's 90 degrees, then you can recognize something as the diameter. So I'm going to give you an example of that. So again, there's my circle. Oh, that's horrible. All right, so on here, let's say I told you that this was a 90-degree angle. And I had these labeled as A, B, C, and D. All right. Well, on here, what segment would be a diameter if it was drawn in? Where's the diameter? What was it? Is it? There's not a diameter in here right now, but if I was to draw one, where would it be? AC. This is a right angle, so if I was to connect A and C, that would have to be a diameter, because if that's a right angle, then it must be inscribed into a semicircle, making AC the diameter. That's what that was saying. The next one, if a quadrilateral is inscribed into a circle, then its opposite angles are supplementary. Now, that makes sense because if we were to have, let's take a look at this figure again. These two are right angles, right? They add up to, each one's 90. They add up together to 180. They're supplementary. Now, the other two angles, they're not 90. But this angle is half of this arc. This angle is half of this arc. Together, those two arcs make a full circle, 360 degrees. So what's half of 360? 180. So opposite angles in a quadrilateral will always have to equal 180. They'll always be supplementary. That goes for any time you have a quadrilateral inscribed into a circle. Opposite angles are going to be supplementary. All right. They also bring back other ideas, like this one. In this problem, the example that's already worked out, they bring back ideas of isosceles triangle. They bring back ideas of triangle sum theorem. So you're going to see other properties mixed in as we do some of these problems. All right, let's scroll this up so we can do some examples. All right, find each measure. So now, on here, we have 1 and 2. All right, we're looking for X and we're looking for the measure of angle W. Well, first off, it almost looks like there's not enough information to find that because there's not a lot labeled. But based on some of the properties we've talked about in this section, we can label something. What angle do I know right away in here? Or, okay, so right angle. So again, we can either recognize, all right, we have this diameter. So this angle is inscribed into a semicircle, which makes this 90 degrees. That's our right angle. Well, now that I know that, these two are the two acute angles in a right triangle, meaning that those two must add up to what? The two acute angles in a triangle are always 90. They're complementary. So we can write an equation. We have X. We have X plus 12. Together, they must equal 90. And now it's a matter of solving that equation. So we have 2X plus 12 equals 90. Subtract the 12, get 2X equals 78. Divide by 2, and X is 39. All right, so this one's 39. For angle W, I have to go an extra step. I have to add it to 12. So x plus 12 or 39 plus 12 gives us 51. There are two answers. On number 3, same idea. We have an angle inscribed into a semicircle. So we should recognize right away the one angle there is 90 degrees. It's a right angle. Anyway, so yeah, you have a semicircle, inscribed into a semicircle. That must be a right angle. So now, since we have a right angle, the other two must add up to 90. 2x plus 4x minus 6 equals 90. And add a solve. Combine our like terms. That's 6x minus 6 equals 90. Bring the 6 over. Minus 6. Divide by 6. Did that wrong? So divide that by 6. We had 6 goes into 9 once, so 36. 36 divided by 6 is 16. So we got 16 for x. That's one answer. But we also need angle t. So plug it back in. 4 times 16 minus 6. Now, I could do that. There's another easier way to find angle t. I already know that this angle. Oh, no, sorry. I lied. That one's 2x this time. So you have to multiply that one out. It's fine. Or 64 minus 6. That's going to be 15. All right, down the bottom. Both of these figures have quadrilaterals inscribed into them. So now the idea we're using here, the opposite angles in a quadrilateral have to equal what? Opposite angles in an inscribed quadrilateral have to equal 180. So on each of these, we're saying them up so that we have equations that equal 180. So I can say 3x plus 110 equals 180. Or I could also say, oops, sorry, I actually grabbed the wrong piece there. Those are opposites. 3x is across from 75. 75 equals 2x plus the 110 equals 180. Now, does it matter which one you solve for? Not really. Again, you're finding x and then you're plugging it back in. So we could subtract 75. You'd be left with 3x equals 105. Divided by 3, x is 35. On this one, same thing. Subtract the 110, you're left with 70. Divided by 2, you get 35. Now, since I did the work for both of these, I actually got the answers I need kind of early there. Because the 3x, I already have what 3x is partway through that problem. I already have what 2x is partway through that problem. So this one was 105. This one was 70. All right, on 7 and 8, same thing. 7 equals 180 and solve. Right. Okay, I'm going to stop there. Your assignment today, instead of having you do both pages, odds like I did the last 2 days, I'm just having you do page 25 all. So you'll have to do all of the numbers on that, just page 25 all. So just that first page. That's your assignment. Again, once you have it done, make sure you post it. I have not had a chance to make this spot on Canvas just yet, but I will. So again, make sure you post it there. Any questions? All right.